Namaste student. Today's topic is combination of solids. Here we are going to see few combinations which are there in our syllabus. First, you can take it as cylinder and cone. So let's see which type of figure we are going to get in our exam. Cylinder cone. That means a cylinder will be given to you and one cone will be provided whose radius will be remain same for both. That means for cone and cylinder. This type of figure you will get when one cylinder, one cone. Another you will get one cylinder but two cone. So this is the example of pencil. You can take it as a pencil, and if you see this one gulli danda, that the gulli is the example for this one. Sometimes the question may be given like this. Your cone will be inside of it. No problem. This type of question will be given to you also. So there are three combinations. You can see this three figure you will going to get in exam. That is the cylinder. First type, that is the cylinder plus cone. Now second one will go for cylinder and hemisphere. If you go for this one, you can see here a great example, a small house. You can see this type of house, and this is the example of house also. You can take it as, and similarly here you can see this one is the example for house, hut you can say. But here if you see, so this is the example of capsule. We'll get in exam on a capsule problem. That means if we'll keep it in a horizontal direction, you can see this is the example for capsule. Okay, now same problem the way we have seen here. This time your hemisphere will be inside of that one. That means we'll get this type of figure inside one, or you may get two also. No problem in that case. So here for cylinder and cone, these three types, and for cylinder and hemisphere you can get this type of problem. So this is your same part. The third one, when you can see that cylinder, cone and hemisphere. The cylinder, cone and hemisphere is a great example when you have the pencil with a rubber. This is a great example. You can see here there is a rubber this side, and here we have a pencil. So this is the example for your cylinder, cone and hemisphere, three combination. Or sometime it may be give you inside of the cylinder also, no problem. Okay, the third one, that is a cone and hemisphere. That means you take this hemisphere here and draw a cone. This is the example for hemisphere and cone. You can take it, or you reverse it. You can see this is what example of ice cream. It's a great example. There is cone and hemisphere mixed with this two. We'll get one example for ice cream. Okay. Now we're going to see, that is cube and cuboid. Cube, cuboid and hemisphere. That means generally it's provide for cube only. You can see somewhere Tom is there. So that is the Gumbad example. So here you will get, this is the example for cube plus hemisphere. This question may be given to you. Next will be, if we'll take it cuboid, no problem in that case, but it will not be equal. We'll get here like this. Sometimes design will be there in any building. We can see this type of figure. Next, that is cube, cuboid and cone. Yes, this type of figure would be there. If instead of hemisphere you can get here cone also, no problem in that case. Okay, one more example. That is the example we're going to see for cube, cuboid and cylinder. Yes, sometime it would be given to you. Okay, this type of figure, one cylindrical pipe would be passed through it. So this type of figure would be given to you in exam also. You can see. So these are the combination. You can see this one. or any more. No, right now this many only we have. So now we need to find their surface area. So generally it asks you total surface area, and many students make a mistake in that case, and we're going to see where they do the mistake and find the volume. Volume is very easy when your figures are outside. That means if I'll ask you find the volume for this one, you need to find separate volume for cone, separate volume for cylinder, and separate volume for hemisphere, and you add them. You will get the volume of the given solid, this solid. For this one also same thing, volume of the hemisphere plus volume of the cone, you will get the volume of this ice cream. If you see this part also, the volume would be asked, then you can find the volume of the cuboid and the volume of the hemisphere. Here also volume of the cube and the volume of the hemisphere. Here quite different because this part will be negligible. So in this case, what we're going to do, we need to find the volume of the cube or cuboid and then volume of the hemisphere, and you need to separate this part and find the height of this one and the volume of this one. You need to subtract it. You will get this one. This is quite high level. We don't have this type of problem in exam purpose. We don't get this type of problem, but you get different type of problem. Okay, not this one. Now here the volume is quite easy, but if we'll see this type of problem where the figure is inside, in that case if we'll find the volume for this figure, please do not add here, you need to subtract it. As you can see that this has been curved out from this cylinder from both sides, so you need to find the hemisphere and you need to subtract volume of cylinder minus 2 times of volume of hemisphere. So here also if you'll see this figure and if I'll ask you find the volume of the solid figure, then what we're going to do, you need to find the volume of cylinder and then you need to subtract the volume of cone and you will get the answer. No problem for the volume. The problem will arise in your total surface area. Students make lots of mistake in that case. Let's see where they do. Now if I'll take here the first one, that is your cylinder and cone. Now here if you see the figure, you can see that the radius, and here you can see the find the height. Okay, now if I'll ask you find the total surface area and the total surface area quite differ. We'll see the surface area also, curved surface area. So let's find the curved surface area. That means this will be excluded. We're not going to add them. Okay, so what we have, and you can see that this is, if we take this plane only, you can see that this is your cone and this is your cylinder, and inside the part is inside is there. That means the circle part is inside, so we'll not take that one as a surface. It will be inside of that solid figure. So surface would be what? Curved surface area, this one, the pi RL plus outside of this one, that is 2 pi RH. This is for your curved surface area. Curved surface area for the given solid. Now you need to find the total surface area. What we're going to do, we'll keep this one same, that is pi RL plus 2 pi RH. Now extra part is what? This base is what? Pi R square. Remember, we're not going to add this pi R square because it is inside of the solid figure. Okay, now if we'll go for next problem, let's see, we'll take this one only. If we'll add here, so what we're going to see here, the two cone, you can see just what we're going to do, we'll just add, or you multiply here 2 times, we'll get the same answer, no problem. But here this time you will not get this part. Why? Because here also you can see that circle is inside. So what we have seen for this figure, the curved surface area and the total surface area remain same. So very much important. If we'll see for this one also, cylinder and hemisphere type, that is a capsule, in that case CSA and TSA will remain same. How are you going to find? Let's find it here. That is a surface area, outside part we need to find, that is a 2 pi RH. And if you see the surface area for hemisphere, curved surface area for hemisphere, that is a 2 pi R square, and plus this part is what? 2 pi r square. Why not this part? Because this two circle is inside of that figure, solid figure. So this will be your answer, that you can take a common here, 2 pi r, and you will get the formula, or substitute in this one the value of r and the h, you will get the curved surface area or total surface area for this solid figure. Okay, now one more we're going to see. Now if we'll take here cone and this is hemisphere. In this case you can see the radius, and there will be height would be given, or sometime the slant height would be given and radius would be given, and you need to find the height using Pythagoras theorem, and you will get the answer. So in this case you can see that the circle part is inside of the solid figure. So here if they will ask you curved surface area or total surface area, both will remain same for this solid figure. As you can see, there is no base area. So your answer would be what? This is the curved surface area of this hemisphere, that is 2 pi r square, plus curved surface area of cone, that is pi rl. If we will take common, you will get the separate formula. Now we're going to see so already we have seen, I think, or any more, cone hemisphere, cuboid. Okay, yes, one more is there, that is a cubical box, and there is a hemisphere. Yes, hemisphere would be the, how are you going to find? You need to subtract the area of this part, that's a pi r square. You need to subtract. First you need to find the curved surface area. If I'll ask you to find the curved surface area, total surface area for this solid figure, so first you will add this one 6a square, and then you add it, that is a curved surface area of this solid figure, that is a 2 pi r square. But you can see here extra part would be there. That means if we take the square and if we take out the circle part from this, you can see here this part are there outside, this parts are there. That means they are also part of surface area. That means to find this one, what we're going to do, we'll take the square, take it square, that is your a square, and you need to subtract the area of circle minus pi r square. If we'll do, you will get the answer very simply. That means 6a square plus, already we have, sorry, in 6a square already we have added a square, so we're not going to add extra part, just we need to subtract here pi r square. Already we have taken here pi r square, 2 pi r square we have taken. Okay. And one circle has been not taken here, so we need to subtract. Why? Because already this part we have taken the whole things, but we need to subtract this part which has been occupied by this one, so we cannot see this part, so we need to subtract here pi r square, and 6a square already applied here, so 6a square plus pi r square. This is short form formula for this type of figure. You will get this type of figure. So these are the problems you will going to see in the question, combination of solid figure. I hope you people have enjoyed. Thank you.